Hello everyone, we want to discuss suspended charges. That means we want to look at two charges that are suspended with a thread from a ceiling, and we want to see what will happen when you suspend these two charges, having mass and even the length of the thread is given to us. Now let's go right away to the question. The question says two tiny balls, each of mass m, are suspended from a common point by a light insulating thread of length L. If they are assumed to be point charges of equal value that repel each other until each makes an angle of what theta with the vertical, what is the charge on each ball? Now let's start like this. Let's say two tiny balls of each of mass are suspended. Let's say they are suspended from this ceiling. Now, if they are suspended from there, let's use a thread of length L. Each of the mass is M. Don't forget, they say they are equal charges. So when you suspend two charges that are equal in their magnitude and also the same size, because if they don't have the same charge, I don't think they will repel, because like charges repel. So apart from being equal, they are also like charges. But this statement is only can be for the fact that they are like charges. Now, if they repel each other, they will now form something like this. After repulsion, they will initially be at this point first, both of them. But after repulsion, they cannot attract. After repulsion, they will now just like two threads now. One is suspending this one, the other one is suspending this. So once they now repel, everybody the two charges will go in their various They will move like this one will move like that. They will have a repulsion force this way. This one will produce another repulsive force this way. Now they now produce a distance between the two charges. Let's call it X. We're not told. Let's call it, because when they repel, when the two charges repel, let's call this one Q, this one Q, having a mass. What is the mass? M, but their weight will not be downward. They will have a weight towards the gravity, direction of gravity, which is mg. This weight also will be here, mg. Their weight will also be mg. So that means the force of repulsion is equal but opposite. They will repel their like charges. Now, this is what will happen. Now, they told us that the mass M are suspended. So the mass M having a weight downward towards gravity. Then the tension in the string, let's say there will be tension T. There will be tension here T. Okay, apart from the tension, there is also they told us that look at the board. They said if they are assumed to be point charges, okay, of equal value that repel each other until each makes an angle of theta with the vertical. This is the vertical and this is the horizontal. So they makes an angle of theta with the vertical. That means each makes an angle of theta with the vertical. So this is the angle they are talking about with the vertical. What is the charge on each? So let's go back again to the question. Two tiny balls, each of mass M, are suspended from a common point by a light insulating thread of length L. This is length L. If they are assumed to be point charges, the two of them are assumed for point charges of equal value that repel, go in their repulsion. This go there, this go there. Okay. Until each makes an angle theta with the vertical, which is this. What is the We want to now find the charge. Now there's something we must do here. If you check the body now that we have here, this particular, let me remove the chart. This particular body now, this is the length L. That means the thread has a length L. This also have length L. Now, but don't forget something here. Look at it. If I extend this one upward now, this is also theta, alternate angle. Here is theta, here is theta. Here is alternate to this angle here. Now, this is what we are going to be having. We have the weight here. The weight is equal to what? Mg. Downward. Now, we have the what? The tension here. That is tension. And we have what? Theta here. If I'm redrawing this diagram, this tree, then this is the what? The force F. And this force F can be gotten. Now, this, let's extend it to this place. Now, this is what? 90 minus theta, but we don't need that one. Now, if you resolve this tension here, resolve it to the vertical and to the horizontal. To the vertical, because it's lying, the angle is resting on the vertical. This is Y and this is X. Because it's resting on the vertical, it will take what? This one will become cos. T cos theta. Now, and Y here will now be what? T sin theta. That means it's resting on the what? On the what? Vertical. So since it's resting on the vertical take cos, while the horizontal will take sin. And it will be like this. Don't forget, if you resolve this one, the direction will go like this. And if you resolve this, it will go up. So now, considering what? Sigma Fy first will be 0. Because the system now is suspended, so it's in equilibrium. Whether you like it or not, because it's not falling off. The charges or the mass is not falling off, so it's in equilibrium. So now, what we're going to do now, we now say what? T cos theta, which is upward force, must be equal to downward force, mg sin theta, equation 1. Now, let's consider what? Sigma Fx equal to what? 0 along the horizontal. It will now be what? T sin theta is equal to what? F. Let's call this one equation 2. Now, don't forget our F can be gotten by what? Saying K is saying what? It's a repulsive force. And it's what? KQ square over S. Now, don't forget that the distance between the two charges. This is one charge Q. This is another charge Q. The two of them are equal charges. That's why I square it. Normally, it's supposed to be KQQ over X squared, the distance apart. Separation. Don't forget when we have two charges, Q and Q, separated by a distance X. How do we calculate the force? This is what the way we calculate for using Coulomb's law. Because they are like charges now, they are equal charges. That's why I put square here. It's clear. Now, that is our K. So you put it there. But there's something we need to do here. Now, since you have equation 1 and equation 2, we can eliminate T. How do we eliminate T? How do you eliminate T? Please note this. Now, we can say divide equation what? 2 by 1. That means what we are going to say now is T sin theta over what? T cos theta. The grammar is that equation 2 divided by equation 1. So equal to what? F. What is our F now? Our F is what? KQ square over S square divided by what? What's our mg? Now this will cancel this, cancel. We are going to have what? Tan theta is equal to KQ square over X times 1 over what? S square over 1 over mg. You were taught that whenever you remove division, this is division now. If you remove division and turn it to multiplication, the 1 will go up, is what? The mg will come down. So we are going to have it as what? Tan theta is equal to what? KQ square all over mgx square. Now what I'm going to do is, because I'm looking for charge according to the instruction here. So what is the charge on each? So if I can find one, I've solved the two. So let me cross multiply. You do that, you're going to have it as what? Therefore, we're going to have KQ square is equal to mgx square tan theta. So how do you make K the subject of formula? So this one implies that you give this. So Q square is equal to divide both side by K. This will cancel. So Q square equal to what? Mg what? S square tan theta divided by K. But recall that what? We can make Q the subject of formula. How? By taking square root of both sides. Take square root of both sides to remove this square. So I want to have it as what? Take square root of both sides. Sorry. So take square root of both sides. And if you do that, this square will cancel square root. So I would have Q is equal to what? This square inside the square root will come out as x. So I would have x square root of what? Mg what tan theta all divided by k. So that is the answer. But remember, x is not given in the question. Look at it now. We're not giving x in the question. We're only giving length. If you draw your what? Your length diagram. This is what we're be having. This is x over 2. How? Let's call this place n. This is n. From n to this point is what? X over 2, because from here to here is x. What will now be from here to this place? This place is equal to this place. So it will now be half. So now from here to this place is L we are given. And this is theta, angle to the vertical. Now how do we get x here? Let us say what? Sine theta equal to what? Opposite over what? Hypotenuse. Let me clean this side. We already have the question. So let me clean. We are looking for charges there. So let me clean this side. Now, we are looking for what? For x. So we can say sine theta is equal to what? Opposite over hypotenuse. Which is what? What is opposite there? X divided by 2 divided by what? Length. That is our what? Then if you now what? Make what? By cross multiplying, this L will multiply what? Sine theta. So I would have x implies that what? X over 2 equal to L sine theta. So how do we make x the formula? Therefore, x is equal to what? 2L sine theta. By the time we take 2 to the other side. So this is our x. So the charge now will not be equal to what? In place of x now, I can now substitute what? 2L sine theta there. So I would have 2L sine theta square root of what? Mg tan theta divided by what? By k. Where don't forget k is equal to what? 9 times 10 by what? 9 Newton meter square per column square. It is what? The column constant. Then we have what? We can use it as k naught. You can take it as k naught anyway. So please, you can, so that you can differentiate it k from k naught. Is k naught, k naught. So you can replace all those one with k naught. Sorry for that. But anyway, just understand that your k is 9 times 10 power 9. So once you understand that, I don't think you have problem with the symbol. I don't think you are going to have problem with the symbol. So just work with that value, the constant. Now our M is what? The mass of what? Each ball carrying this charge Q. Our what? L is length of thread, length of what? Of insulating thread. The length of what? Of insulating thread. Insulating what? Thread. Then what again do we give? Are we giving there? We're giving what? G is 9.81 meter per second square. Acceleration to gravity. Then the angle to the vertical. What is the angle? L is length. Okay. Theta. Theta is what? Angle suspended with the vertical. What again are we giving there? Okay, I've given what theta is given a mass is already known. Then Q is what? Charge, the point charge or the charge on each ball, which we have solved for. Don't forget this Q now. Q can also, this formula can be equal to NE. I think I've given that analysis under introduction of electrostatics. Q equal to NE because sometimes we can be asked to find the number of electrons on each of these balls. So the number of electrons will now be N equals to what? Square everything here, divided by the what? E. Everything here divided by E. We give us what? Because it will now be Q over E. Q over E will now be our what? Our N, number of this number of what? Of electrons on each ball. On each ball. So that will now give us your analysis clearly. Anything you want to find, just substitute everything here. After you have solved this, put it here, you get your number of electrons on each ball. I believe that this formula should help us to what? To solve problems. This formula should help us to solve problems. So in case you want to talk about suspended charges, so this will help us to solve a lot of problems. Then you want to find the force between two charges. The force between the two charges, suspended charges. Don't forget your x is going to be what? All this. Put it there. So your x will now takes what? It takes the value of 2x. So the force on each will now be what? Which is equal to what? KQ square divided by what? 2L sine theta all what? Square. Because your x is now this value. So you put it here, replace it with x, then it's all square. A square here. So you can get your what? That means after you have solved for your what? For your charges, each charge, you can put it there and get your what? Your force. So that is another one thing you must understand. Thank you very much for watching my video. Please ensure you like and subscribe and ensure you tell somebody about this channel. Thank you very much for watching. Have a wonderful day.